Good morning. My name is Patrick Frye. I'm going to present you one of the last demolition projects our company has achieved, a simultaneous blasting of 3 chimneys. First, a short summary of the presentation. Created in 1956, Cardem is a subsidiary of Eurovia, a Vinci company since 2000. The company has 7 divisions in France. We also have a bomb clearing department. The current workforce is 350 employees, and 45 of them are qualified for blasting operations. Let's have a quick look on our equipment. We have excavators from 1.5 to 120 tons, and of course, all specialized equipment and tools. Our engineering office allows us to be completely independent on all phases of studies and development. As you can see, that department is able to work on many subjects. On the following movie, you'll discover the general context of the worksite and the specificities of this dismantling. Afterwards, we'll focus on some points.
Built in 1951, the Richemont thermal power plant was linked to the steel industry of the Lorraine region. It closed down permanently on October 1st, 2010. Cardem, the French leader in demolition and a subsidiary of Eurovia, a Vinci company, was selected to demolish the 3 chimneys. This demolition project represented 6 months of work, conducted with EDF as the contracting authority and Cardem as the prime contractor. Cardem's role consisted of demolishing 3 chimneys standing 75, 111 and 115 metres high respectively. The smallest chimney, part of Generating Unit 3, was located at the eastern end of the power plant and had a brick-lined interior and a concrete exterior. The chimneys belonging to Generating Units 4 and 5 comprised 2 tapered cylinders in reinforced concrete, the first one dating back to the startup of the plant, with a variable thickness from 19 to 8 centimetres from bottom to top, and a second one with a constant thickness of 15 centimetres. The latter was added for reinforcement after several years of operation, thereby creating a double thickness. The chimney of Generating Unit 4 was made of bricks between the heights of 12 and 72 metres. Finally, the chimney of Unit 5 had a metal tube interior between the heights of 12 and 115 metres. Given the safety and technical context, Cardem decided to proceed by blasting.
Primary issue on the worksite is safety. Specific measures are defined according to the different safety and environmental risks defined by both management staff and our health and safety department. To sum up, the goal is to identify the risks, delete them if possible, or reduce them and deduce the adapted measures.
Due to the very poor overall condition of the chimneys, Cardem decided to perform a thorough analysis of the structure. This analysis consisted of running compression tests on the concrete of each of the 12 sides of each of the 3 chimneys, using magnetic resonance imaging on the concrete reinforcements and performing scans of the bottom parts of the chimneys. This analysis procedure was highly specialised and extremely innovative in the approach to a demolition. It was carried out in addition to the usual site check of all structures. The goal of this in-depth survey was to ensure that the technical choices made were the most adapted to the very unusual context of these structures. Additionally, unstable elements were inspected and removed by a team of rope access technicians specifically selected for this work.
2, 1, 0.
As you can see, nothing is left to chance. The little details often make the difference. All the necessary means to satisfy our client are implemented, which means a good achievement, on time, without environmental incidents, and above all, no accidents. The use of explosives on the worksite means maintaining total control of the project, from monitoring the structure provisional stability to dealing with the blast debris. This is all made possible by the contribution of each and everyone in the combination of in-house skills passed on over time.
5, 4, 3, 2, 1, 0. This project, 6 months of work, was a challenging job and therefore drove us to develop specific methods and customized systems. Cardem has extensive experience in every area of demolition and has distinguished itself by conducting large-scale, technically challenging projects.
Wow, I'm relieved. Chimneys went down correctly. All this happened only 10 days ago. I wonder what my presentation would have been otherwise. Seriously, let's focus on 3 specific points of that blasting. First, building and equipments nearby. Second, general state of the structure, and then management of vibration and dust. As you can see, the chimneys were close to buildings and equipment to preserve. Our job consisted in demolishing the 3 chimneys, preserving the rest of the equipment, which is only a few meters away from the chimneys. On the other hand, the high voltage electricity pylons are still in use and are very sensitive to vibrations and dust. Over here. The other points we had to deal with was the general state of the chimneys. By visual check, we could determine that they were badly damaged by time and carbonation of the concrete, but the obligation of process preservation led us further in our analysis. First, the diagnosis was completed by rebar analysis, ferroscan, by scanning and MRI. Then the diagnosis of the concrete strength and properties was determined by core boring and sclerometer measures. These measures were taken on the 12 sides of the 3 chimneys, and the result went from around 16 to 80 MPa on each chimney, and this at the same level. So all around the chimneys, at the same level, there were huge differences in our measures, causing several risks. Because of the poor concrete resistance, the hill may not resist at blasting time. The concrete hinges cannot support the weight of the chimney. And the 2 tallest chimneys have 2 concrete layers that don't make a single wall. They have a tendency to split. Plus, inside and outside layers don't have the same properties. The 2 tall chimneys had a 7 meters depth basement. If the hill had collapsed before the chimney take their orientation, the whole chimney could have fall inside, get stuck, and end up balanced. See on the following animation what could have happened with an early collapse in the basement, and how we prevented it with refilling the basement. Now, because of the incapacity of the concrete hinges to support the weight of the chimneys, And again, to make sure the chimneys would fall the right direction, we designed and developed customized metallic hinges. Now see on the animation how this innovation was crucial for the precision of the fall. Now finally, after taking all previous measures to ensure that the chimneys would fall at the right place, we had to deal with the general state of the structure for blasting preparation. To avoid the risk of split due to separate layers with different concrete properties, we decided that the explosives would be placed in holes bored in staggered rolls. And about vibration and dust control during the blast, as shown during the movie, several measures were adopted. We loosened the ground of the reception area, we dug a trench around the area, simple but efficient measures confirmed by our very precise pre- and post-fall vibration survey. The dust was mainly contained by water and nettings. As you all know, it's not unusual for chimneys not to fall the right way. Our client also knew it. For this specific context, with all the buildings and equipment nearby to preserve, they needed more than our word or explanations. They needed to see precisely what was going to happen and to have a guarantee on results. See on the 3D animation following how the method was introduced and how it really happened. Now this project was a big success, not only because it finally went well, but because we were able to explain to our client how everything was going to be managed before it happened. Even more, to show him exactly how the blasting was going to be done, the precise way these chimneys would fall. The requests of our clients were, first, a precise, almost surgical procedure that needed 4 months of studies. Then a very short delay. The real job on the chimneys started in September. And overall, a management of risk to guarantee safety. All during the project, Operations were showed before being realized. Our client was constantly involved and was confident because, step by step, he could have a virtual look at what was going to happen next and why. Nowadays, for that type of jobs, I bet that it's our client's expectation that will lead us to always more anticipation and technology. Thank them. They contribute to keep us innovative. Thank you for your attention.